Hello everyone. In this lecture I shall discuss the area of the surface of revolution. Okay. So which needs to recall the previous lecture, the length of the arc, that is the rectification. Okay. Now we classify the curves into the Cartesian system, polar system, parametric system, pedal system, etc., on which we have discussed the length of the arc. Okay. Now coming to the Cartesian system, suppose you are given y is equal to fx and from the x is equal to a to x is equal to b points on the abscissa. So what is my ds by dx? It is 1 plus root over of dy by dx whole square. So this implies what is your ds? ds will be 1 plus dy by dx whole square root over dx. Now if I find the length of the arc, what is s, from the point A to B, suppose within the point A to B. So SAB will be just simply the integration of A to B, this 1 plus dy by dx whole square root over dx. Already we have discussed it. Similarly, here what will be your ds? So ds will be 1 plus dx by dy whole square root over dy. Then similarly, what is your ds here, right? Here ds will be x dash square. Suppose I write x dash square and I write y dash square root over dt, right? Then what will be your s? This length of the arc, L or s, it will be integral from t, suppose t1 to t2. It will be x dash square plus y dash square root over dt. Accordingly, in polar system, what is your ds? Your ds here will be, this is in pedal system, ds will be r by square root of r square minus p square dr. So this dr, okay, where your p will be expressed in terms of r. Similarly, in your polar system, what is your ds? ds will be r square plus dr by d theta whole square root over d theta, where you have your theta within the range, suppose you say theta 1 to theta 2. Right, here similarly we have, suppose your y ranges between c to d. Right, similarly here your t lies in between some t1 to t2. Right, so before the details of discussion of the area of the surface of revolutions, in fact, suppose I rotate a two-dimensional curve, say circle, right, about x-axis, then it will generate say sphere, and we find the surface area of the sphere. It will 4 pi a square. A is the radius. Okay. So before the details of the discussion, let me to introduce myself. Myself, Professor S.K. Paikray, Susanta Kumar Paikray, currently working as a professor of mathematics at Veer Surendra University of Technology, B.Sc, Burla, Sambalpur, Odisha, India. Okay. At this stage, my appeal to you is that if you feel these lectures are useful, please like and subscribe to this channel. It will boost my motivation to upload the subsequent lectures. If we go through my playlist, you will find a series of lectures on engineering mathematics. Okay. I expect this will be helpful for you. So please forward this lecture to your friends for their benefits. Okay. So now let me to discuss the formula for the area of the surface of revolution. Now we discuss the formula for the area of the surface of revolution. Accordingly, we have the different forms of the curve. Suppose you have the Cartesian system. Here y is equal to fx, about rotated about x-axis, and the ordinate between x is equal to a to x is equal to b. Right. So the surface area of the solid generated by the revolution, as I told, if you rotate a circle, it will give you a sphere here. So what is the area? The formula for the area is integral a to b 2 pi y ds. Okay. Now this ds, what is your ds? This ds is this, ds is this. So you can write it. We can write it. It is integral a to b 2 pi y ds is 1 plus dy by dx whole square root over dx. Okay. Now if the curve is expressed in terms of x is equal to fy within the ordinates c to d, then we have what is your area A? Area will be integral c to d 2 pi x, right? 2 pi x, it is your dy, right? So you will be able to write it. It is ds, sorry, it is ds. So you will be able to write it integral c to d, it is 2 pi x, it is ds by dy. Now we substitute the formula for this. So it is integral c to d 2 pi x, it is square root of 1 plus dx by dy whole square dy. Now this is the limit for your y is equal to c to y is equal to d. So it is enough. You should remember this formula. The surface area is given by this formula. Okay, and here you should remember the surface area is given by this formula, right? Your area, surface area, your A is equal to this, right? Accordingly you have your parametric form. In parametric form, suppose your x is equal to your f of t, y is equal to suppose your g of t, then what is your area here? And the limit of t is known from t1 to t2 say. So area will be integral t1 to t2, it is 2 pi y ds you say. So now this will be t1 to t2, 2 pi, your y will be gt. Now in view of your ds, it is square root of dx by dt square plus dy by dt square dt. So now this is the formula for the surface area under the parametric form. Similarly, if you have your polar form say r is equal to f of theta. So the limit of theta is known, say it lies in between theta 1 to theta 2. Then the surface area is given by integral here theta 1 to theta 2. It is theta 1 to theta 2 in the same line. This is the fundamental one. Okay, you can write 2 pi y ds. So this will be, ds will be here in polar form of ds will be taken, right? Here ds will be, so you can think of here x is equal to r cos theta, y is equal to r sin theta. In that line you think of. So it will be here integral theta 1 to theta 2, right? 2 pi y will be here r sin theta and ds will be square root of here r square plus dr by d theta whole square, and it is d theta. Okay, so this is the formula for the surface area under your polar curve. Now it is important to take the limit of integration. This limit of integration is important. We have to see the revolution. We have to visualize the rotation, the revolution to find the exact limit. So coming to one solved example, you are asked to find the area of the surface of the solid generated by the circle about x-axis. Means we have a circle, right? We have a circle. If we rotate the circle about x-axis, right, then this will lead you to a sphere. Right? So what is the surface area of sphere? It is 4 pi square. From school geometry you know, and we have to find it. Okay, so now the circle here is center 0, radius a. Now even if we have only half of the circle is here, right, and if you rotate it also, then we will get the whole sphere we will get, right? So this limit of integration depends upon the upper half of the circle here. Means this is my a0, this is my 0a, right? So your x varies from 0 to a. Now if I express it my, what is your y? Y is equal to a square minus x square root over. Okay, if I take the limit over here, here 0 less than x less than a, then I have to multiply 2 times because we have this and this, right? So what is my surface area here? The surface area will be 2 times integral from 0 to a, because this is multiplied twice because of the symmetry here. It is 0 to a 2 pi y ds. This is the formula. So now this is my Cartesian form I am taking. So this will be 2 times integral 0 to a pi. What is your y? Y is equal to a square minus x square root over a square minus x square root over. And what is your ds? ds is 1 plus dy by dx whole square root over, and it is your dx. So now we find this dy by dx. So we are given x square plus y square is equal to a square. If I differentiate it, right, if I differentiate it, what I am getting? 2x plus 2y dy by dx is equal to your 0, right? So your dy by dx is minus of x by y. Okay, so here let it be y. So because y is going to be cancelled here, it is 2 pi y. Okay, so now I will substitute here. It will be twice integral 0 to a 2 pi y is my y. It is 1 plus x square by y square root over dx. Okay, so this will be my 4 pi integral 0 to a, it is y. If you simplify it, it is y square plus x square root over, and root over of y square is my y dx. Now this y and y cancelled here. Okay, so now x square plus y square is my s square, so it is 4 pi 0 to a, it is a dx, is not it, because it is your s square. So now you integrate it, so this will be 4 pi a, right? The integration of dx is your x, here 0 to a, so this is equal to 4 pi a, it is a minus 0 is 4 pi s square, right? So what we are getting? The surface area of this sphere, is not it? So if you rotate the circle here, then about x-axis you generate this sphere, and the surface area here, as you learn in our school geometry, 4 pi s square, and we prove it, it is 4 pi s square. So now important to find the limit of the integration. Okay, don't take the entire sphere, right? Don't take the entire circle here, right? Or you can take the limit from minus a less than x less than a, minus a to a, right? Then no need to multiply 2. So here we are multiplying 2 here for this and this regions. Okay, so now let us solve the second example. So coming to example 2, find the surface of the solid generated by the revolution of this curve. Actually this is the asteroid, the name of this curve. We don't bother about the name, about x-axis. Also I have discussed in rectification chapter, right? So the asteroid is given by this. Okay, given by this is my asteroid, right? And this is a0 0a, right, minus a0 minus a0, and it is 0 minus a. This is the asteroid. Now it is important to note that, right, if we take the upper half of this asteroid, and if we rotate, revolve it, if it is not there, then also this solid will be generated, same solid will be generated. Okay, so the limit will be considered from the upper part, right? The limit will be considered from the upper part. Now if we want to bring into the parametric form, x is equal to a cos q theta, right, a cos q t, and y is equal to my a sin q t, then you x to the power 2 by 3 plus y to the power 2 by 3 is a to the power 2 by 3. So this approach will be easier here. So now this t or theta, if I take theta or t, means it is in the sense of my rotation here. It is my sense of the rotation here. So in the first quadrant, the rotation is 0 less than theta less than pi by 2. It is my parametric form. I take t or I take theta, that doesn't matter, right? So this is my parametric form. So because we have the two regions here, this and this, so we are going to multiply 2 with this. So what is the formula for the surface area? The surface area, my A or S is equal to integral from theta 1 to theta 2, 2 pi y ds. Okay. So now theta 1 to theta 2, I take 0 to pi by 2 with I multiply a 2 here to cover both the regions. So it is 2 pi. What is my y? Y is a sin q theta. A sin q theta. What is my ds? ds is dx by d theta whole square plus dy by d theta whole square root over d theta. I write theta or I write t, that is immaterial. Okay. So what is my dx by dt? You see, dx by d theta will be 3a cos square theta. Again derivative of cos theta is minus sin theta. Okay. So it will be my, it is 4 pi 0 to pi by 2. A also I can take out. It is sin q theta. Dx by d theta will be my whole square of this. Okay, whole square of this. It is my minus 3a s square cos 4 theta sin square theta. Then plus here dy by d theta I find. It is 3a sin square theta, 3 whole square. So 9s square. 9s square sin 4th theta. Derivative of sin theta is cos theta. Square again. So cos square theta. And it is my d theta. Okay. So this is equal to my 4 pi a integral 0 to pi by 2. It is sin q theta. 9s square taken common. It becomes my plus, because whole square I am taking. I am taking the whole square. So it becomes my plus. So 9s square taken out, it becomes here 3a. Then if I take common here cos 4th sin 4th, cos 4 theta sin square theta. So I can take common here sin square theta cos square theta. So it will give you cos square theta plus it will give you sin square theta d theta. So this is my 1. This is my 1 here. So this will be 4 pi a integral 0 to pi by 2 sin q theta. It is my 3a and it is sin square theta cos square theta taken out. So it becomes sin theta cos theta. This is my 1 d theta. Okay. So this will be my 3a taken out. Okay. So it is 12 pi a square 0 to pi by 2. It is my sin 4th theta into cos theta d theta. So as usual you can integrate it. You can put sin theta is equal to some t, and accordingly cos theta d theta is equal to dt, and likewise you will proceed. And here I can tell you another easy way of integration, right, by using beta and gamma function. Also this beta and gamma function, you can see my lecture series beta and gamma functions, an easy way of integration. And the integral formula here is 0 to pi by 2 sin to the power p theta cos to the power q theta d theta is here gamma of p plus 1 by 2 into gamma of q plus 1 by 2 divided by twice gamma of p plus q plus 2 by 2. Okay, this is the formula. Right, this is the formula. Again here gamma of n plus 1 is here n gamma n. Right, accordingly here if I ask what is gamma 5 by 2, it will be gamma 3 by 2 plus 1. So it will be 3 by 2 gamma 3 by 2 is again half plus 1. Okay, so 3 by 2 into 1 by 2 into gamma half, and here gamma half is root pi. Gamma 1 is 1. Okay, so you can refer to my lecture on beta and gamma functions. So accordingly it will be what? It will be my 12 pi s square. It will be my gamma of p is my 4 plus 1 by 2 is my 5 by 2 into, this is my 1, right, 1 plus 1, gamma of 1 plus 1 by 2. So it is your gamma 2 by 2 divided by gamma twice gamma p plus q plus 2 by 2, 4 plus 1, 5 plus 2 means 7 by 2. Okay, so this will be 12 pi a square. So this is gamma 5 by 2 will be what? It will, gamma 5 by 2 will be your 3 by 2, then 1 by 2, then gamma 1 by 2. Then this is your gamma 1. This is your gamma 1, isn't it? Gamma 1 divided by twice. Gamma 7 by 2 will be 7 by 2. 5 by 2. Decrease by 1, 5 by 2. Then decrease by 1, 3 by 2. Then 1 by 2. Gamma 1 by 2. So what is the value of gamma 1? Gamma 1 is 1. Now this gamma half and gamma half cancelled here. Okay, then here half cancelled here. 3 by 2 cancelled here. This 2 and 2 cancelled here. Okay, so this will be 12 pi a square divided by 5, right? So this is your answer. So this is your answer. However, you can integrate it. You can integrate it by your plus 2 technique and you will find the same answer, 12 pi a square by 5. You will get the answer in this way, right? However, this approach is quite easy. If the limit of integration is 0 to pi by 2, it is of the form of this, right? For the details, you can see the lectures on beta and gamma function for such type of integrals. However, this formula is enough. Okay, so this is my answer. So this is my desired answer. Now coming to example 3, find the surface of solid generated by the revolution of the curve. This is actually name of the curve is Cardiac. It is Cardiac. CARDIOID. Okay, this is the spelling. So is it not of the form your r is equal to f theta? So it is in polar form. Okay, but if you recall the curve here, the curve is like this. The curve is like this. This is the shape of the cardiac. But we don't bother about the curve, right? We don't bother. But for the limit we need it. Okay, so if this is not there, this revolution is enough to generate the solid here, and the limit will be from it is 0 to pi. Okay, so 0 less than theta less than pi. What is the surface area here? Your surface area A or S will be equal to integral 0 to pi. Okay, it is 2 pi y ds, right? And what is your ds in polar form? It is 0 to pi. 2 pi y is your r sine theta. ds is your r square plus dr by d theta whole square root over d theta. Is not it? So this is my r. Accordingly you find dr by d theta. So this will be, so now this will be integral 0 to pi 2 pi it is r sine theta. Here r square is square root of r square. R square is a square 1 minus cos theta whole square. Then dr by d theta, derivative of cos theta is minus sine theta. Okay, into a sine theta, right, whole square, right? Derivative, what is dr by d theta? Dr by d theta is a sine theta, right? It is d theta. It is actually plus is given. Okay, so it is minus. So again the square of this will give you the same thing here. So if you simplify it, it is 2 pi 0 to pi here r sine theta. So you substitute the value of r. Okay, you substitute the value of r. What is your r? R is your a into 1 plus cos theta, a into 1 plus cos theta. This is my r, and sine theta is your sine theta. Then this is a square, and this is plus. This is a square. A square taken out, it becomes your a. 1 plus cos theta. is 2 cos theta by 2, right, whole square, because you know cos square theta is 1 plus cos 2 theta by 2. So similarly 1 plus cos theta is 2 cos square theta by 2, right, and it will be here sin theta whole square, sin 2 theta is 2 sin theta by 2 cos theta by 2. So you can write it 2 sin theta by 2 cos theta by 2 whole square d theta, and you have the square root of this. Okay, if you simplify it, you will be getting, so if you simplify it, it is 2 pi 0 2 pi, it is again here 1 plus cos theta is 2 cos square theta by 2, and it is a square taken out. Okay, and it is 4, so 4 will be taken out, right, it is here sin theta will be again 2 sin theta cos theta, 2 sin theta by 2 cos theta by 2. If you simplify it, actually this was the plus, okay, this was the plus, so this was the plus, so accordingly I just open it, a plus b whole square. Now sin square theta plus cos square theta is 1, so it will give you this. Now if you multiply it, it is 2 into 2 into again one more 2, it will be 16 pi square 0 2 pi, it is cos to the power 2 1 1 fourth theta, and into it will be here sin to the power 1 theta by 2, right, d theta. Now if I put theta by 2 is equal to t, implies d theta is equal to here 2 dt, so here 0 less than t less than pi by 2, so it will be 32 pi square, right, 0 to pi by 2 cos 4th t into sin power 1 t dt. So at this stage you can apply the formula integration 0 to pi by 2 sin to the power p theta cos to the power q theta d theta is equal to gamma of p plus 1 by 2 gamma of q plus 1 by 2 divided by 2 gamma of p plus q plus 2 by 2, as we did in the previous case. Okay, it may be cos sin cos, it is immaterial, and what we are getting here, and we are getting 1 by 5 we are getting. Okay, so we will be getting here, so it will be here 32 pi square, it is gamma of 5 by 2 gamma of 1 gamma of 7 by 2. Okay, so this is equal to 32 pi square gamma of 5 by 2 3 by 2 1 by 2 gamma 1 by 2, and gamma 1 is 1, and 7 by 2 will be 5 by 2 into 3 by 2 into 1 by 2 gamma 1 by 2. So gamma 1 by 2 1 by 2 cancelled, half cancelled, 3 by 2 cancelled. Okay, it is 2, so this 2 and this 2 cancelled, so only 5, so this is 32 pi square divided by 5. Okay, this is your answer. So coming to one more example, here the carrier is like this. Okay, so here the figure is just this reverse. Okay, so this is the carrier, but the limit is same, this is 0 and pi. Okay, 0 less than theta less than pi. So what is the area? Integral 0 to pi 2 pi y ds. So this is equal to integral 0 to pi 2 pi 2 pi y is here r sin theta, ds is r square plus dr by d theta whole square root over d theta. Now in place of r you are going to substitute 2 pi, r is here a into 1 minus cos theta into sin theta, it is here r square plus dr by d theta whole square root over d theta. If you proceed in the same way, it will again give you the same answer, 32 pi square by 5. This will be answer. Let's solve the last problem. So here the ellipse is given, So if you simplify it, it is x square by 4 square plus y square by 2 square is equal to 1. Okay, so the major axis and the minor axis, it is 0 2, it is 4 0, right? So about the major axis, what is the area, is equal to integration of 2 pi y ds, right? The limit will be this coordinate is 0 0, so this is 0 to 4. If we multiply, so this 2 here, if I take this and for this we multiply 2, it is 0 to 4, right? So it will give you about your major axis. So this will here 4 integral 0 to 4, it is pi. Here y, you simplify your y, so here let y be y and ds will be 1 plus dy by dx whole square root over dx. Okay, if you go on simplifying, it will give you finally pi root 3 integral 0 to 4 64 by 3 minus x square root over dx. So it is of the form here s square minus x square root over dx, right? And it is x by 2 root over of s square minus x square plus s square by 2 here sine inverse x by a. Okay, this is the formula. So if you apply this formula and simplify, it will be here 8 pi into 1 plus 4 pi root 3 by 9. Now by about the minor axis, right? About the minor axis, what is the area? Integral y1 to y2, right? 2 pi x dy. So this will be here it will be 0 to 2, right? 0 to, it is 0 to 2 will be multiplied, so twice 0 to 2 pi x, and here this will be here dy 1 plus dx by dy whole square root over dy, right? And likewise if you simplify it, and you will be getting, it will be 4 pi integration 0 to 2 16 minus 4 y square plus 16 y square root over dy. Okay, and if you go on simplifying, it will 8 root 3 pi 0 to 2 by root 3 square plus y square root over dy. It is integration of s square plus x square dx. So it is x by 2 root over of s square plus x square plus s square by 2 log x plus root over of s square plus x square. Okay, you apply this formula and go on simplify, and you will be getting the final answer 32 pi 1 plus 1 by 6 root 3 log root 3 plus 2. You should solve it. The video is getting lengthy, so I am not calculating the details. You should calculate of your own. In the subsequent lecture, I will discuss volume of surface of revolution. Okay, so here in area and volume, it is important to find the limit. Okay, so for which we need the knowledge of curve tracing. That curve tracing, some standard curve you should remember. Okay, and that beta and gamma function, right? 0 to pi by 2 sine to the power p theta cos to the power q theta d theta, or if you replace it, sine cos to the power p theta sine to the power q theta d theta, right? It will that gamma of p plus 1 by 2, right? P plus 1 by 2 gamma of q plus 1 by 2 divided by 2 times gamma of p plus q plus 2 by 2. Okay, this formula you should adopt for easy calculation sake. Okay, now again my appeal to all of you is that please like and subscribe to this channel, which will boost my motivation to upload subsequent lectures. So let us close this lecture here. Thank you all. Have a nice day.